We've all learned that a nucleus contains protons and neutrons. If we zoom in, it'll look something like this. But we've also learned that protons are positively charged. So shouldn't all of these positively charged protons repel each other? Why doesn't a nucleus split apart? The answer has to do with the fact that inside a nucleus, protons and neutrons are incredibly close. Let's watch what happens when we take two protons and bring them together. Coulomb's law says that the force of repulsion is proportional to the inverse of their distance squared. R represents how far apart they are. So as we bring them closer, what happens? R gets smaller and the force increases. And if we bring them a little closer, what happens? R gets smaller and the force increases. And if we bring them a little closer, what happens? Shockingly, they start to feel a tremendous attraction. Does this mean that Coulomb's law is wrong? It doesn't apply at all distances? The answer is no. There is another force called the nuclear force, which exists in nature. This is the first time we've ever encountered the nuclear force, but it's there. It's the reason why protons can bind together. If we bring these protons a little closer, the nuclear force will actually weaken, and eventually it'll fall to zero. And this is the point where stable atoms form. But there's more we could say about why nuclei form. Imagine you take a proton and you weigh it on a scale. The mass that you get is 1.007 atomic mass units. And then you take a single neutron and you weigh it on a scale, and you get 1.009 atomic mass units. If you combine a proton and neutron together and weigh them, what do you expect to get? Probably something like 1.007 plus 1.009, which gives you 1.016, because 7 and 9 make 16. But when you actually weigh their mass, what do you get? 2.014. This is wrong. Simply by combining a proton and neutron into a nucleus, they have less mass. Why is this true? The answer has to do with Einstein's famous equation, energy equals mass times the speed of light squared. When you bring a proton and neutron together to form a nucleus, something interesting happens. When the nucleus forms, a photon of light is emitted. That photon has energy, and where does the energy come from? It comes from mass. When the nucleus forms, the proton and neutron actually lose mass. Where does the mass go? It's converted into a photon of light energy. Unsurprisingly, this process is reversible. If you take a nucleus and you blast it with some energy, then you can separate it out and convert that light energy back into mass. So our original question, why don't protons go flying apart inside the nucleus, has two answers. One reason is because of the nuclear force, which acts only when protons are incredibly close. And by the way, the nuclear force is felt not only between protons, but also between neutrons, and also between protons and neutrons. But there's another reason why the protons don't go flying apart. To break those protons apart would require that you put back in the energy that the protons lost when they formed a nucleus. So we finally answered our question.